So today we're going to demystify one of the most fundamental concepts in all of programming. How can code actually think? We're going to explore how Python uses conditional statements to make decisions, turning simple scripts into reactive, intelligent programs.
It seems almost magical, right? I mean, how does a simple script decide whether to grant you access to something, or how to calculate a discount, or change how a character behaves in a video game? It's a great question, and you know what? The answer is surprisingly straightforward.
At the very heart of all this complex logic is a really simple, very human question. What if? What if the user is over 18? What if the password they typed in is correct? This what-if kind of thinking is exactly how we give our programs the power to choose.
All right, so let's dive right in with the most basic building block for all decision-making in Python, the simple but incredibly powerful if statement.
A good way to think about the if statement is like a security guard standing at a gate. The guard checks one specific condition. Maybe it's your ticket or your ID, and if and only if that condition is true, they let you through to run a specific piece of code.
Okay, let's see this in action. So here we've got a variable, age, and we've set it to 20. The if statement then asks a question. Is age greater than or equal to 18? Well, since 20 is definitely greater than 18, the condition is true. And because it's true, the program runs the code inside that if block, printing eligible to vote. Simple as that.
Now, for those times when your action is super simple, Python gives you this handy little shorthand. A lot of programmers use this because if you only have one thing to do, it's just cleaner. It keeps the condition and what happens right on the same line. It's doing the exact same thing as the full version, just, way more compact.
Okay, but this brings up a really important question. In that last example, what if the age was, say, 16? The condition age greater than or equal to 18 would be false, and the program would just, it would do nothing. It just skips right over that print statement and moves on. So what if we wanted to do something else instead?
And that's where our next tool comes in. To handle both the true case and the false case, we bring in a partner for the if statement, the else statement. This is a total game changer. An if-else structure creates a literal fork in the road for your code. If the if condition is true, it goes down one path. But if it's false, it automatically takes the other path, the one defined by else. There's no other option. It has to choose one of the two.
All right, let's trace this one out. The age is 10. The code first checks the if condition. Is 10 less than or equal to 12? Yep, it's true. So the program runs the code in that if block, printing travel for free, and it completely ignores the else block. The decision has been made.
Now, what's really interesting about this slide is how Python lets us condense that entire four-line if-else block into one single elegant line. It's called a ternary operator. You can literally read it like a sentence. The result res will be pass if the marks are greater than or equal to 40, else it will be fail. It's just an incredibly clean way to handle these simple assignments.
Life is rarely a simple yes or no, right? Programming is the same way. What if you're not just checking for pass or fail, but you need to assign letter grades, like A, B, C, or D? A simple if-else just isn't going to cut it here. We need a way to check multiple different conditions.
And for that, Python gives us elif, which is literally just short for else if. This thing is the perfect tool for when you need to create a chain of checks, letting your program navigate through several different possibilities.
So the way this elif chain works is like a waterfall. The program starts right at the top, with that first check you see here. If that condition is false, it just flows down to the next one. If that one's also false, it keeps flowing down. But as soon as it finds a condition that's true, it runs that code, and then, boom, it jumps out of the entire structure, completely ignoring everything else below.
Okay, let's walk through this with age set to 25. First check, is 25 less than or equal to 12? No, so we move on. Second check, is 25 less than or equal to 19? Still no, we move on again. Third check, is 25 less than or equal to 35? Yes, it is. So the code prints young adult, and the entire rest of the chain, including that final else, gets skipped.
All right, let's move on and look at a couple of more advanced tools for more complex situations. Sometimes you need to check a condition, and then, based on that result, you need to check another, even more specific condition. And this is what we call a nested if statement. It's kind of like a branching path that has even smaller branches shooting off of it. You're basically putting a decision inside of another decision, which gives you much more fine-grained control over your program's logic. So in this example, the first thing we do is check if the person is a senior. The age is 70, so that outer if age greater than 60 condition is true. And only because that's true do we even look at the code inside. Then we check the second condition, is member. Since that is also true, the program prints 30% senior discount. If is member had been false, the code would have hit that inner else and printed the 20% senior discount instead.
So nested ifs are super powerful, for sure, but they can get messy fast. For situations where you're just matching a single variable against a bunch of specific values, we call this pattern matching. Python gives us this newer, much cleaner structure called match case. As you can see in this table, match case is just way more readable for this specific job. And wow, this shows you just how elegant match case can be. We match the variable number, which is 2. The code then goes down the list. Does it match case 1? No. Does it match case 2 or 3? Yes. That little vertical bar just means or. So it prints 2 or 3, and it stops right there. And that underscore at the end, that's a wildcard. It's a catch-all that acts just like an else block for any other value.
Okay, so we've gone through if, else, elif, and even some of these more advanced structures. But let's kind of zoom out for a second and talk about the big picture here. Why is this stuff so important?
So, if there's one thing to take away, it's this. Without conditional statements, a program is just a boring, static list of instructions that runs the exact same way every single time. Conditionals are what give a program a brain. They're what give it the ability to react, to adapt, to behave, well, intelligently based on whatever is happening.
And I mean, you see this stuff everywhere. Think about it. The simple logic on a login screen, if the password's right, let them in, else show an error. It's in the bad guys in a video game, the dynamic pricing on Amazon, even the system that controls the traffic lights on your way to work. It's all powered by these decision-making structures.
By mastering these concepts, if, else, and elif, you've really unlocked the core of all programming logic. You now have the tools to build programs that aren't just static, but are dynamic, responsive systems. So the real question is, now that you've got the tools, what decisions are you going to let your code make?